guys, today we're going to learn the three properties of logarithms, okay? So just like when you're solving an equation and you're, doing things, distributing, there's always rules to things. So I can go with logarithms a couple different ways. If I have a logarithm and it's two things multiplied together, that's a product. To split that up, I can split that up with addition. So multiplication and addition go together when we're dealing with logarithms. I can give you 2 or 3 logarithms added together, and you could condense it to one log with multiplication, or you can take a single logarithm and break it apart using addition. So if addition and multiplication go together, then division and subtraction go together. Okay, so multiplication and addition go together, division and subtraction go together. That's the product property and the quotient property. The other rule is the power property. If you have a logarithm and there's an exponent inside the logarithm, that exponent can be pulled in front. Same thing with if there's a number in front of a log, it can come up to be an exponent. Okay? So the first example is really just practicing some rules. If I give you log base 9 of 5 equals 0.732, rounded, and log base 9 of 11 equals 1.091, then let's use some properties of logs to approximate these. If you didn't have a calculator, you can't type in log base 9 of 5 over 11. A lot of times questions like this will appear on ACT, okay, because it will give you the values, because on the ACT they say you can do it without a calculator. So if it says log base 9 of 5 over 11, I can split this up as 2 logarithms. I could say it's log base 9 of 5. Division is the same thing as subtraction. Log base 9 of 11. 5 over 11 becomes log base 9 of 5 minus log base 9 of 11. And then if I substitute that in with the decimals, I have 0.732 for log base 9 of 5 minus 1.091 for log base 9 of 11. What does that equal? Typing that in your calculator, you get negative 0.359. All right, so figuring out what log base 9 of 55 is. Well, what's another way to write 55 using a 5 and an 11? I know 5 times 11 is 55. So if I wrote this as log base 9 of 5 times 11, how do you split up multiplication? Multiplication is the same as addition. So log base 9 of 5 plus log base 9 of 11. 0.732 plus 1.091 gives me 1.823 as my answer. All right. If you're given log base 9 of 5 and log base 9 of 11, and you're asked to find log base 9 of 125, using 5 and 11, what is another way to write 125? Well, I know that 5 to the third is 125. So if I need log base 9 of 5 to be by itself, you could use the power property and take this exponent and pull it in front. So it becomes 3 times log base 9 of 5. Now that the log base 9 of 5 is by itself, I could take 3 times 0.732 and get 2.196. Okay, so that's just a little introduction on how to use the rules. Division goes with subtraction, multiplication goes with addition, and exponents can go in front. So we're going to do two types of logarithm problems today. We're going to expand some logarithms, and that's where we take one log and we break it into multiple logs using the addition, subtraction. And then we're going to go the other way. I'm going to give you a whole bunch of logs, and we're going to condense them, put them back together as one single log. So let's expand first. The first problem we're going to do says expand log base 5 of 2, x to the 6th. So how many pieces are inside that logarithm? There's a 2 and an x to the 6th. So I know I'm going to have 2 logs. Now this is 2 times x to the 6th. So what undoes multiplication? Addition. So I'm going to have log base 5 of 2 plus log base 5 of x to the 6th. But that's not completely finished, because anytime we have an exponent inside a logarithm, that would need to come in front. So our final answer would be log base 5 of 2 plus 6 log base 5 of x. Okay? 2 times x to the 6th got split up with addition, this log plus this log, and then we had to bring our exponent in front. All right, so log base 7 of y over 3x squared. So the first thing I see is this division. I'm going to have log base 7 of y, that is what's on top. Division splits into subtraction, and then I have log base 7 of 3x squared. Y over 3x squared. But that's not completely expanded, because I have a 3 and an x squared inside this logarithm. So that would need to get split up again. Log base 7 of y minus log base 7 of 3. Since 3x squared is multiplied together, I would have plus log base 7 of x squared. And since I'm dividing by all of that, that would be in parentheses. Y over 3x squared. And then, since there's an exponent, that would need to come in front. So log base 7 of y minus log base 7 of 3 plus 2 log base 7 of x. Now, since this is all on the bottom, I could go ahead and distribute that subtraction in and get log base 7 of y minus log base 7 of 3 minus 2 log base 7 of x. So if something's on top, it'll be added together. If you have multiple things on the bottom of your fraction, each piece that's on the bottom can be used with subtraction here. For example, let's try another one. Log base 2 of x squared y on top divided by 3z to the 4th. So I see 1, 2, 3, 4 pieces here. Log base 2, log base 2, log base 2, log base 2. Now, what is on top? I see x squared and I see a y. X squared times y gets split up with addition. I then have a division sign, so I know I'm subtracting. And what am I subtracting? I am subtracting a 3 and a z to the 4th. So each piece of that can have a subtraction sign. Even though it's 3 times z to the 4th, I can use a subtract and a subtract because I'm dividing both pieces. Both the 3 and the z to the 4th are on the bottom. So if you wanted to say it was subtract log base 2 of 3 plus log base 2 of z to the 4th, you could. But then if I distribute that subtraction in, okay? So then that final piece to expanding this would be to take your exponents and pull them down in front. So my final answer would be 2 log base 2 of x plus log base 2 of y minus log base 2 of 3 minus 4 log base 2 of z, because those two things had to come in front. All right, look at B. We have log base 2 of 12, x to the 6th, y to the 8th, and z to the 2nd. I see 1, 2, 3, 4 things multiplied together. So log base 2, log base 2, log base 2, log base 2. What are the pieces that I have? I have 12, x to the 6th, y to the 8th, and z to the 2nd. 12 times x to the 6th is addition. X to the 6th times y to the 8th is addition. Y to the 8th times z to the 2nd becomes addition. All that multiplication becomes is addition. And then I have 1, 2, 3 parts with exponents. So those 3 numbers have to go in front of the logs. Log base 2 of 12 plus 6 log base 2 of x plus 8 log base 2 of y plus 2 log base 2 of z. All right, let's try and go the other way. Now I'm going to give you multiple logs, and I want you to be able to condense them and put them all back together as one single log. So in the end, as our final answer, you have log base 3 of something. Okay? The first thing I know is that if there's a number in front of a log, it can get pulled up to be an exponent. So log base 3 of 7 squared minus log base 3 of x to the 5th. Right? I pulled all my exponents up. And then what do I know about subtraction? Subtraction is the same as division. So I'm going to have something on top over something on the bottom. Well, what's the first piece that I have? 7 squared over x to the 5th. So my final answer is log base 3 of 7 squared over x to the 5th. All right, looking at the second one. First thing I should do is look. There's a 2 in front of that log. So log base 8 of x squared minus log base 8 of 5 minus, let's pull that 3 up, log base 8 of y to the 3rd. Okay, so then I know I have to have log base 8 of something, and then I just start going through. X squared is what I'm going to have on top. Subtraction is my division. What's on the bottom? A 5. And what else is on the bottom? A y to the 3rd. So since I have multiple subtractions in a row, that means all of that becomes on the bottom. Okay, let's look at example 5. We have 4 log base 2 of x plus 5 log base 2 of y minus 3 log base 2 of z. Pulling exponents up first gives me log base 2 of x to the 4th plus log base 2 of y to the 5th minus log base 2 of z to the 3rd. So I know in the end I have log base 2. What am I starting with? I have x to the 4th. Plus means multiplication. I am multiplying it with y to the 5th. And then I have subtraction, which means division. And I am dividing by z to the 3rd. So my final answer is log base 2, x to the 4th, y to the 5th, over z to the 3rd. Okay. Last one. Log base 5 of 6 minus 9 log base 5 of a plus 7 log base 5 of b. Bring the 9 up. Log base 5 of a to the 9th plus log base 5 of b to the 7th. Okay, so I know I have log base 5. I know I'm starting with a 6. I know I have subtraction, so I'm dividing. I am dividing by a to the 9th. However, b to the 7th is not in a parentheses, so I'm not dividing by b to the 7th. I am timesing it by b to the 7th, which means that the b to the 7th is really on top of my fraction, okay? All right, so what are your 3 rules? Your 3 rules are multiplication splits up into addition, and if you have addition, it condenses to multiplication. Subtraction is the same as division. A single log with division can be split up into multiple logs with subtraction, and vice versa. And that a number in front of a logarithm is really the exponent inside the logarithm. Okay? We will continue working on this in class, and you need to keep working on your practice pages. Okay? We got 2 more videos to go. See y'all later.